Hello everyone, Paul here from Fixing Foundations. Today we are going to be going over some basic principles regarding square roots. In particular, we will be talking about the concept of a principal square root. And before I talk about that, I want to spend some time talking about squares. So you might already know that a rectangle's area is equal to its length times its width. And you may also know that squares are a type of rectangle, and you can actually find the area of a square by just taking one of its sides and multiplying that number by itself, because all of the sides of a square are equal. So, to just help you understand this principle, let's just take a look at this really small square here. It has a length and width of 1, and if we map it over this grid, we can see that it has an area of 1 as well. It only takes up 1 square in terms of area. Or if I take a square that's a little larger, let's say I take this square that has an area of 9, it has 4 sides. Each of these sides is 3 units long, and you can actually count the number of squares inside of it. It actually has a total of 9 squares as its area. So hopefully that helped you understand that principle a little better. And now we can take a look at what it means to have a radical expression. So you can see here that I have illustrated a radical expression. The number in red that's inside is known as the radicand. The symbol used to describe it, or the symbol used to indicate that it's a radicand in purple, is known as the radical, and this whole thing is known as a radical expression, which I have circled in light blue. And you can actually see here how it relates to the square. So you see we have an area of 49 for this square, and we also have 49 as our radicand. And additionally, when we carry out the process of simplifying this radical expression, we basically reverse engineer the process that was used to create the area of a square. So if we assume that the radicand was the area of a square, what we're basically asking ourselves with this radical expression is what number was multiplied by itself to get this radicand? And that is the answer to this problem. The number that was multiplied by itself was 7, because you can see here that this square has a length and width of 7. So 7 is the number that can be multiplied by itself to create the radicand within this radical expression. Now, hopefully that helped you understand the concept of what a square root is. Now let's just take a look at some examples, right? So we'll start with 4, and we know that if we were to multiply 2 by itself, we would get 4. So therefore, the way of simplifying this radical expression would simply just be to express it as 2. With the number 9, we'll ask ourselves, what number would we have to multiply by itself to get 9? And 3 times 3 equals 9, so the answer to this is going to be 3. Looking at a larger number, let's say we had 36. What would we multiply by itself to get 36? Well, 6 times 6 equals 36, so therefore the answer to this is 6. What about 64? 64 is larger still. Well, 8 times 8 equals 64, so therefore the square root of 64 equals 8. What about 32? Well, before we concluded that the square root of 36 is 6. So it has to be something a little smaller than 6. But what if we did 5, right? Well, if we did 5 times 5, this would give us 25. So that can't really be the answer either. So it has to be somewhere between 5 and 6. It has to sort of be in the middle of these two numbers somehow, right? Maybe that's not the best way of expressing it, because that kind of looks like a plus sign. But it has to be somewhere between 5 and 6. So what can we do? Well, one way you might be able to solve this is by taking out the calculator. And the calculator actually has a little square root button on my calculator. It's right here. So if I were to click it, it's going to open up the square root, and I can put in 32, and you can actually see we get something close to 5.66. I'm going to round it to the nearest hundredth. So I'm going to write that the answer to this is 5.66. Or it's roughly equal to this, 5.66. I'm even going to erase the equal sign, and I'm going to put like a roughly equal sign, just so that you know that it's not actually completely equal to this. Because if we were to take 5.66 and we were to multiply it by itself, we'll get something, it's close to 32, but it's not exactly 32. But because with our calculator we put it in, we can assume that this is at least close to the correct answer. Now, there is actually a way of simplifying this that many college algebra professors prefer that will give you a more exact answer, but that is a little more complicated. I think that falls outside of the scope of this video. However, I am going to make a video about that in the future. So, if you would like to watch that video, check the description of this video. You may just find a link to that video there. In the meantime, I hope you found this video helpful. If you learned something new, please leave the video a like. If you'd like to see more tutorials related to mathematics, please subscribe to my YouTube channel. And if you're interested in online tutoring, check out the description of this video. You may find something helpful.